Hello and welcome to this session, Get Started with Serverless Workflows. My name is Marcia Villalba. I'm a developer advocate for AWS. Today we are going to learn how to decouple your serverless applications and what is the functions and what is the need for them. So the problem started when Robert wanted to add that order button in their blog post. And we built in the previous episode a Lambda function that is basically taking care of that. Is handling the payment of the order, then it's sending that to the payment service, it's also saving things into the database, it's sending the order to the restaurant, and everything is interfaced with the client with an API gateway, and we are using DynamoDB to store. So this is great, it works, it scales, but we just built a fat Lambda. And you might be like, what? What? A fat Lambda? What is that? Well, there is a good practice out there that it tells that simple functions are the best practices with doing Lambda functions. You want simpler functions that do one thing and one thing only. They're easier to test, they're easy to maintain, they're easy to reuse, and they're more secure. We need to give less permissions and all that stuff. It all comes from the single responsibility principle from the solid paradigm, if you have heard about it. And here it was coined by Robert C. Martin or Uncle Bob, and it says a class should only have one reason to change. And we extrapolate this to the serverless world, and we'll say that Lambda functions are simple, they do one thing and one thing only, so we know what they're doing. We can test them properly with unit tests. We don't need to worry too much about how many integrations they have because they usually have one. And then because they are single purpose, you just need to give very particular permissions for that particular purpose, because if you have functions that are fat and they're doing many things, then it's quite hard to give granular permissions. So we want that in our Lambda functions. So we will see when you start building serverless applications that you will build microservice applications, and you think, yes, microservices are great. We want microservices that do the one thing and one thing only. But then if you zoom in into one particular serverless microservice, you will see that there is multiple Lambda functions, there is queues, and there is other components in there as well. So a serverless microservice is not one big Lambda function that does it all, but it's a set of multiple Lambda functions that are doing many things. So in the case of Robert and his serverless application that he's building, he might have in his order service, whatever we want to call it, he might have a couple of Lambda functions or more that are handling one the order, one is handling the payment, there might be a queue or something else. We'll see later step functions, there might be a database in the microservice, there is API gateway. So there are many, many, many resources inside that microservice. So let's get to build and see how we can solve that problem that Robert had. So this is our architecture, and what we want to do is to decouple those two Lambda functions so they are less busy, because now one is doing everything. So we want one Lambda function to make the payment and keep tracking the database, and then another one to send the order to a restaurant, and also it will take care of the database. And the question here starts with how we connect these two Lambda functions together. Well, we can send from Lambda A message to Lambda B. That's totally doable, but it's not a good practice because now we are coupling Lambda A with Lambda B. So whenever we want to change either of these Lambda, we need to change the other Lambda, and that's not something we want. So in this first approach, what we are going to do is add a queue. I will add an SQS, that is the simple queue service from AWS that will handle the message sent from Lambda A to Lambda B. So whenever Lambda A finishes sending the payment and everything is fine, it will grab it, put it in the queue, the message, and Lambda A will trigger because a new message is in the queue, and it will send the order to a restaurant. So now our application is asynchronous. Before, our application was synchronous, meaning that the client will make the HTTP request and will get the response right away if the order succeeded or not. Now with this setup, the client will not get a message if the order succeeded or not, because is asynchronous and we cannot see what happened in the second Lambda until it's finished. So the client will get like, yeah, we just made your order, and later on in your user interface, you can add a checkup for what is going on with that particular order. So for doing this project, we will start from the code that we built in the previous episode. So you can go and get the code from here. This is module 2, so go and check that out. And there you will also find some other resources. So if you're interested, that's the starting point. So this is the code that we built in the previous episode, and now we add a new function. This is our template YAML where our infrastructure lives. So here is the definition of the first function, the make payment function, that we are now refactoring into take two functions. One for making the payment into the payment service, and then one to make the order into the order in the restaurant service. So I will be adding that make order function. We are giving where the code is in the make order function directory, in the order module, and in the handler method. It's another node 12 using the runtime, and then it's triggered by an event in a queue, in this case in the SQS queue that we are going to create in a second. And to create a queue, we are going to use CloudFormation, but it's super simple. We just give that we want a queue, and that will create it for us. So this is how you create a queue in CloudFormation using infrastructure as code. Actually, it's even easier than going to the console and creating it. The next thing we want to do is to add some new permissions for the first function in order to put a message into the queue. So we want to use the SAM templates that we learned, policy templates that we learned previously. And then we want to add a couple of one environmental variable that is the queue name that then we can use in order to send the message to the queue. So this is basically all we need in our infrastructure. This is around 40 lines of code that does the two functions, one API gateway, one queue, and one Dynamo table. So if we go to our code, we can see the payment function here, and we can see now this is the payment function refactor, sending the message to the queue. So we can see that we are, again, getting the information from the event object in the HTTP request. In our case, we are saving the item to Dynamo, and then we are doing the payment manager, we are doing the payment. And if everything is good, then we use the SQS manager. That is another service that I made that is using the AWS SDK to send a message to this queue that we just created, and it sends the order ID. So the only thing that is going to be in the message is the order ID. We don't need anything else. And then we will basically update Dynamo and tell the Dynamo table that now the payment has been okay, and we can respond that the order was sent to the restaurant. If there is an error, we can do that the payment had an error and send the error. And this is the code for our order function. So the order function, you will see that the event object is a little different. Here we have event.record and then the square bracket 0 and body. And this is very different than the one that is sent by the API gateway when there is an HTTP request. This is an SQS event object, and SQS will send a bunch of events. It will batch them in a package. So that's why we see the array of records there in this case, because we are only sending one event and we have a batch of one, that's by default. Then we are going to grab the first element in the array, but if you can put them all together and process many events together. And this will give us the order ID. You can always go, if you want to know what is inside the event object, you can always print that event object in the console. That's my way to know whenever I'm trying something new with a Lambda function with a new trigger, I always print the event object and see what is going on. And then you can see that we send the message to the restaurant manager and we send the order ID. And then we update the item in the Dynamo table. We tell them like, yes, now everything is good. And then if there is any problem, we return the money and we finish. So if we want to make sure that everything is good, then we can go to our AWS console. I show you how to check it with CloudFormation. Now I will show you how to check it from the Lambda console. So you can go ahead and open the Lambda platform and go to applications and go to the applications that you just deployed. There in the overview, you can see the API endpoint that you will use in Postman later and all the resources that were created when you deploy this CloudFormation stack. They are here and they're all accessible by a link. So good, we're done. Let's go. No. There's still a problem. When we use queues, it tends to be hard to coordinate multiple Lambda functions. If there's an error in the second Lambda function with the payment, we still need to do SAM handling. We need to, it's hard, and if we want to add more steps, then we need to add more queues and more decoupling, and it's very hard. So that's one of the problems with asynchronous applications and Lambda functions in general, that when you have long workflows, it tends to be quite hard to follow. So we might have different access to databases, we might put things in queues, and at the end of the day, it becomes a little chaotic. That's why we might try to sequence Lambda functions to make them more efficient. We want Lambda function A, B, and C because we want simpler functions that do one thing, and we want to put them in a chain and make them go like that. Another thing we want to do is to run them in parallel so we can make them more efficient and make our runtime shorter because we put a lot of things in parallel and we take advantage of the capabilities of Lambda to run many things at the same time. Or we want to choose to run one part of a code instead of another one, depending on some kind of input. We can do that in some Lambda function, but we need to add that business logic inside the function, so it's very coupled. And these two Lambda functions, well, these two pieces of business logic now exist inside one function, and that function is doing two things. So we don't want that. If you have errors, if you're calling a third-party API and you want to retry because that API is not responding and you want to retry a couple of times, you can do inside Lambda, but it's again adding more business logic. Or if you want to have a try catch finally set up inside your function, you need to write it as well. So in order to solve that problem, we have AWS Step Functions. Step Functions provides a state machine. So a step machine is basically a collection of steps that are split into the different states. So it's a typical workflow example. We have step 1, step 2, step 3, and if we can do splits, we can do parallel executions, we can do all kind of things. So basically when one state is running, that state is the one is running, then it goes to the next state, and you can pass input from one state to another so the workflow can execute. So this is basically Step Functions. It's a state machine in the cloud. It's a serverless service, so it's fully managed by AWS. You just define the AWS Step Function that is a state machine. You will see how we define one later. And you can integrate it with all kind of AWS services, and it's quite neat. So how they work, basically you define the state machine, and basically each step is called the state. Then you can move from one state to another in what is called a state transition, and you can reutilize components. For example, a Lambda function can be used in multiple parts of the state machine. We have different types of states, the tasks that are executing some work, for example, calling Lambda, a choice that you are making a decision if we go this way or that way based on an output or input, a wait, we wait for X amount of time, parallel, execute things in parallel, map, process in an array, each of the element and do something, succeed, we're good, we finish, fail, we're bad, we finish, and then pass, we just pass the input to the output. It's quite handy sometimes. Step functions connect to multiple AWS services, so there's many integrations. We are going to see the step functions with Lambda, but you can do it with other things as well. So now let's refactor our code to use step functions. So the first thing we want to do is to change this into use step functions, and we need to find the state machine. The state machine is that what we were saying, that is it's full of states and different tasks, and they do different things. For doing that, we are going to use the Amazon state language. That is basically JSON, and it's specific JSON type of language that it will define the different parts of your state machine. So basically your state machine will draw into something nicer. There's many plugins. I will show you one in Visual Studio Code to draw your state machine, but you can also see it in your AWS console. So it's not that you're writing it blindfolded. So in our example, we have multiple types of states. We have a task state, we have a choice state, we have a fail, and we have a succeed. So I will show you those in more detail. So when we want to perform a task, the basic one is to call a Lambda function. We can also call a polling worker. We can pass parameters to an API, so we can directly call the third-party service if we want. But in our case, we want to perform a task. So in our state machine we have there, we can see that it starts and basically it makes a payment and does a task. Then we will ask if the payment is successful, and then we will make an order, and that's another task, that's another Lambda function. And then if the order is successful or not, then we will finish. And if there is any problem with the payment, there will be another function that is handling the payment failure. So here we can see how we can define a state of a task with Lambda function in the state machine language definition. So basically this is the way you will do it. You will put the type task, then you will give the resource, and you will see how we do the mapping between our SAM template and the state machine. But in this case, it's the ARNN of the Lambda function that we want it to run here. Then we put the next step that we need to run. In this case, is the order successful, because this is the make order. So we want to do that choice step. And then if we have some input, basically if this task needs some input to execute, and in this case is the payment.order information, so that's what it will input and what we'll see in the event object of this Lambda function. And then if there is any kind of output, in this case is the order. So then we have the making a choice type of task, type of states, and basically it's like a switch. Let's do this or that based on some input. So this is pretty interesting, and you can add this business logic in your state machine, and then your Lambda functions end up being very simple. So your state machine will look something like this for the choice, that you will need to give the type, that is a choice, and then the different choices that you have is an array. So basically what is the variable that you're looking at to make the decision, and if that variable is true, in this case if the payment is valid, then we go to the make an order. But then if there is any error or whatever, we have this default action that is the task, is the state payment failure. Then the succeed is basically to stop an execution successfully, and we have one there that is the order is placed. So after we do the choice and we make sure that the order is successfully placed and paid, we can say, hey, this is done, complete, and finish the execution of the state machine. And the same is with failure, that it will stop the execution of the state machine, but it will fail and it will tell us that there was some error. So if we want to render this in our computer, we can use this tool. This is a Visual Studio Code extension that is called the AWS Toolkit, and it will allow you to draw the state machine. If you have it written in the Amazon State Machine language, you can basically use this toolkit to draw the state machine with the command palette. After you install the extension, it renders the drawing, and that's pretty helpful to write your state machine if you want to do a more complex one. So I totally recommend it to have it installed, because this makes it so easy, so you don't need to deploy this application into cloud until you are certain that everything is working and there is no error in your state machine. Now we have our state machine, and we want to add the step functions into infrastructure as code, because we talk how wonderful is infrastructure as code. We could go to the AWS console and create the step function there, but we are not doing that. We are going to use it as a SAM resource, so we are going to create in our template YAML a new resource for the state machine. And it looks something like this that is in the screen, but don't panic, we will go step by step and analyze what each of these parts are doing. So this resource is the state machine, and in the top we will define what kind of step functions we are going to use and where is the a JSON document that defines the step machines. We have different types of step functions. We have standard and express. The standard can run for 1 year, the express for 5 minutes, and it has some different things. But for this type of application, I think with a 5-minute step function, we have more than enough. And then we have the definition URI. That's where our state machine definition is, the one that I just showed you, that little drawing. Then we have the definition substitutions. And if you remember in the task, when I was showing you how to execute a task for the make order, there was the resource, and that has make order function ARN. And that's basically the substitution on the mapping between the function ARN that we want and that name. So we will map the make order function ARN to the real ARN of that function that we will get from the infrastructure template. So that's what we are doing there, it's just mapping. Then we have the configuration of logs. We want to enable logging in our step functions. We are going to analyze the logs at the end of this presentation, so you will see how that works. And then finally, we are giving permissions to the step functions to invoke this Lambda, because like everything in AWS is born without permissions, and it needs permissions to put elements in the cloud and in the logs, and it also needs permissions to invoke these free functions. Now we have the free functions. The first one is the payment function, and we are going to hook these step functions directly to API gateway. So basically what is coming in the HTTP request body, the step function is what the first task will get. So that's what we have there. And then we are going to basically do what we were doing before, do the payment and save something into Dynamo. But you can see there that there is this return, and that's the output of this task, of this step function task, that will be shared with the state machine and passed to the next state. Then we have the order function that is basically will receive an input, and this input, you will find it in the event object, and you can see there that input path in the definition of the state machine is the order ID. So basically in the event object, we will only have the order ID. And then again, it has an output that will be passed into the state machine again to do this choice of the order successful or not. So basically now in our first function, in the payment function, we have these 3 elements that we need to pass in the body: the products, the amount, and the customer. And we will basically run it with Postman. So if you want to get the endpoint, you can get it from your Lambda applications. You will see the endpoint there. So you can basically get that one. It should be the same as before, but just in case you didn't have it. And there you can see all the resources that were deployed. So I just put that, and I can execute this function, well, this state machine now, because it's executing the function and then another function afterwards. So, and we can see that the result is this weird thing is again a asynchronous invocation. So we are not getting back from the state machine like the order was placed or anything like that. So that's one of the drawbacks of this. We can see the logs of the execution in the AWS console. If we go to step functions and we go to CloudWatch, we can see the logs. And because we enable everything in the log group, you will see all the steps and how each of the steps on the state machine work. So you can see when something started, when the execution started, when the task started, when like super details on each of the logs. And this is great for debugging if you have a very complex state machine. These logs are super appreciated because you can really go into the details and see why my function is not getting that input or what my choice is getting as an output. So this is super, super helpful. So what we have built, basically we have built a step function that is triggered by an API gateway, and inside the step functions there are 2 Lambda functions and a state machine that we just shown many times. And those the step function basically is making the payment, is keeping the order in sync in the database, and it's also calling the restaurant. We saw also that the state machine returns some weird gibberish that it might be a little confusing. So I will link you in the resources in here another video that is an extra that you will see how you can make your step function execution asynchronous so you can get the order information, order result right away when this finished. But I only had 25 minutes to finish this. So in that link, you can find the code for all the modules and as well this extra video that might help you out. So thank you again for your time. I hope you enjoyed this session and ask me any questions on Twitter. My messages are open. Ciao, ciao!
Well, hello there, you amazing tech people, you. Listen, thank you so much for stopping by to check out this video. However, there is so much more great content out there to be found. So make sure to subscribe to the Build on AWS YouTube channel. And while you're at it, click that bell icon to be notified about the latest and greatest in videos made by builders for